immemorial, people have been dreaming about discovering worlds similar to our own planet. Today, we're as close to it as we could get. Among the thousands of exoplanets pinpointed beyond the solar system, dozens are similar to the Earth to this or that extent. Is there at least one that could realistically become our second home? Cosmo. The first in outer space. The first exoplanets were discovered back in the late 1980s. Since then, the number of detected ones has increased hundredfold. According to statistics from January 2021, over 4,000 planets in other systems have already been discovered. Apart from these, several thousand candidates likely to be given this status have been registered. With sufficient evidence from Earth-based observatories, most of them are going to become officially confirmed exoplanets. The overall number of planets in our galaxy may supposedly be over 1 trillion. From 5 to 20% of these are close to our Earth in terms of their size and composition. Not all of them are in their host star's Goldilocks zones, that is, not all of them are habitable. Still, according to scientific estimates, there are not less than 300 million potentially habitable planets in the Milky Way. Exoplanets differ very much in terms of their environment. Their dimensions may be enormous, some even beating Jupiter. But there are also comparatively smaller ones, close to our Earth in size. Some of these bodies are hot, consumed with oceans of molten lava, whereas others are encased in a shell of permanent ice. There are planets out there made entirely of oceans, with not a bit of dry land on them, while on others, sulfuric acid rains or diamond snow are a regular occurrence. Various techniques are used for discovering other worlds. As a rule, it is next to impossible to spot an exoplanet by simply looking through a telescope. That is why in 2009 Kepler was launched, the first space telescope designed for searching for planets beyond the boundaries of the solar system. The telescope's cameras had 42 charge-coupled devices, or CCDs, with a total resolution of around 96 megapixels. With a field of view covering about 25% of the sky, and coupled with a 1.5-meter mirror of the telescope, it was able to detect astronomical bodies within 3,000 light-years from the Earth. In the 3.5 years of productive operations, Kepler managed to spot over 3,500 exoplanet candidates. The status of over 2,000 of these has already been confirmed by repeated observations. It was in this period that the smallest of known exoplanets today was detected. The diameter of Kepler-37b is just 35.7% that of the Earth. The telescope was also instrumental in registering several stars and brown dwarfs. The transit method was used by Kepler in the search for exoplanets. This method is based on observing the star's luminosity. If the supposed planet passes between the parent star and the observer, this will be noticed in the telltale decrease in the star's luminosity. The extent of these fluctuations in luminosity directly depends on the ratio of the stars and planets' dimensions, while their regularity allows one to estimate the object's orbital period. The transit method requires accuracy in measurements. Changes in a star's spectrum account for less than 2% and are usually tenths or even hundredths of 1%. Ripples in the atmosphere, dust and precipitations negatively affect results produced by Earth-based telescopes. That is the reason why telescopes based on automatic space stations are used for searching for objects beyond the boundaries of the solar system. Unfortunately, in 2013, 3.5 years into the mission, the Kepler Space Telescope had several major equipment failures. In 2018, the spacecraft ended science operations completely. Kepler was the first spacecraft to be created specifically for looking for exoplanets. However, most of the objects it managed to spot happened to be too remote and dim to study them in any satisfying detail. That is why the next space research complex had slightly different parameters. Kepler was succeeded by the TESS telescope launched by NASA on the 18th of April 2018. Its main object was searching for rocky exoplanets orbiting the brightest stars within 200 light-years from the Sun. This telescope also used the transit method. And here is the spacecraft's brief profile. TESS is equipped with 4 refractors with a 24 by 24 degree field of view and a 10 cm aperture. The spacecraft's peculiar orbit allows it to cover both the northern and the southern parts of the sky, which is approximately 85% of the entire sky. Photos are taken by 4 cameras, and the resolution of each camera's CCD is 16.8 megapixels. TOI 700D is one of the most notable objects discovered by TESS. This exoplanet became the first object of the kind comparable to the Earth in size, and which found itself in the habitable zone of its star. It orbits TOI 700, a red dwarf lying slightly over 100 light-years away from the Sun. It is a small and rather cold star. Its temperature is half that of the Sun, and its mass and radius are just 40% those of the Sun. TOI 700 is peculiar for its high stability. Not a single flare has been registered on it since the beginning of observations. A star's stability is a positive feature, because bursts of activity are able to divest its planets of their atmospheres and be generally pernicious for potential life on planets' surfaces. There are at least 3 planets orbiting TOI 700. The one closest to it, TOI 700b, is comparable to the Earth in size. Its mass is approximately 1.07 times that of our planet, and its radius differs from that of the Earth by not more than 2%. Unfortunately, TOI 700b is too close to its host star. It is within about 0.06 astronomical units, and a year on the planet lasts just 10 days. In addition to that, chances are it is tidally locked, that is, it faces the star with one in the same side. This means that the planet is likely to be scorching hot. The planet lying further from its star, TOI 700c, is thought to be a mini-Neptune. Its mass may be from 5 to 13 times that of our Earth, and its radius is 2 or 3 times that of the Earth. It takes TOI 700c 16 days to complete one orbit around its host star. Located closer to the star than the inner border of the habitable zone, it must be too hot for life to originate and evolve there. TOI 700d is the third and at this point the remotest planet in the system discovered by now. It takes 37.4 days to complete a full orbit, which by the way lies along the inner edge of the habitable zone. The mass of TOI 700d hasn't been gauged precisely and may be anything from 1 to 3 times that of the Earth. At the same time, the planet's radius is just 20 to 30% bigger than that of the Earth. TOI 700d is thought to be a rocky world, but its exact composition is not yet known. The amount of energy received by the planet from its star is 86% that of the amount we receive from the Sun. Assuming the planet's atmosphere is similar to ours, the steady-state temperature on the surface of TOI 700d is estimated at 268.8 Kelvin, or 4.3 degrees Celsius below zero. However, due to the greenhouse effect or other features of the atmosphere we may not know yet, this figure may shift either up or down. There is no precise data on the eccentricity of TOI 700d, but it is thought to be small at around 0.11. As the planet's orbit finds itself at the inner edge of the Goldilocks zone, the planet's eccentricity, however small, may incidentally turn out to be perceptible when the planet comes too close to its star from time to time, thus actually leaving the habitable zone. Still, with a year on the planet lasting slightly over 1 Earth month, such unfavorable periods are expected to be rather short. If there are living creatures on TOI 700d, then they might be able to weather the harsh spells in a state of anabiosis. Alternatively, they could adapt or migrate to less inclement areas. Even though the data acquired by spectral analysis of TOI 700d can't be enough for making conclusions, there is a chance that there is liquid water on the planet's surface. Then there is bound to be the greenhouse effect too. which will help the surface temperature to reach favorable values. As I've already mentioned, TOI 700d, along with the other known planets in the system, is highly likely to be tidally locked to its star. If this is the case, there should be a stark difference in temperatures between the sunny side and the shadow side. This contrast could be leveled off by a dense atmosphere, but that would cause powerful hurricane winds. Although the main mission of TESS has been accomplished by now, it still has enough resources to carry on operations. The telescope will continue taking snapshots of the sky, including the Milky Way plane, which is the most challenging direction for observation. Over 2,100 exoplanet candidates have been discovered by TESS in the course of the main mission. Not less than 66 of them have already been confirmed. Apart from that, 6 supernovae flares have been registered, 3 exocomets identified, and a great number of photos taken of small bodies in the solar system. The latter were not objects of the main mission, but are of course of scientific interest. TOI 700d is still guarding its mysteries and waiting for its explorers. Great hopes are placed on the new orbital telescope James Webb, which may help investigate this world and a number of other ones. The new telescope is supposed to provide images of not only exoplanets lying closest, but also detect their moons and carry out spectral analysis of their surfaces. The launch of the telescope is planned for the 31st of October 2021. If all goes according to plan, first data will be available as soon as next year. Will we ever discover a world that could rightfully be called the second Earth? And if we do, will we be able to reach it? Distances in space are just too much for humans. Could it be that we're confined to the limits of our system forever, allowed only to gaze at the vast, infinite universe?